This is section 5.3, writing equations in point-slope form. Point-slope form looks like this. Y minus y1 equals m times x minus x1. Here 1 is the subscript of x. It just means that it's a value for x. The y1 and x1 denote the coordinates of the point that you're given, and as usual, m is the slope. The y and the x without the subscripts will remain the variables. So for example, if you have a point 2,5 and a slope of 2/3, we want to write the equation in point-slope form. Now using our old method to get slope-intercept form, you would normally set the slope equal to the change in y divided by the change in x. So it would look like this. 2/3 equals y minus 5 divided by x minus 2. And to solve this, you would cross multiply. So you would get 3 times the quantity y minus 5 equals 2 times the quantity x minus 2. You would then divide both sides by 3 to isolate the y variable. So your result would be y minus 5 equals 2/3 times the quantity x minus 2. This is actually the point-slope form and its derivation. That's how we arrived at point-slope form. Now normally you just take the point and the slope and insert it into the equation. You wouldn't go through this derivation like this, but this is to show you how they arrived at the equation. For example, when I take a look at the form, it tells me to subtract the y value from the point y, so the left side of the equation becomes y minus 5. And the right side of the equation should be the slope times the quantity of x minus the x value, so that becomes 2/3 times the quantity x minus 2. Therefore, the equation in point-slope form should be y minus 5 equals 2/3 times the quantity x minus 2. Now let's try another one. If you have a line with a point 1,6 and a slope of 1/2, we're going to write the equation for the line. Before you do that, you have to remember the form. Y minus y1 equals m times the quantity x minus x1. So here the equation must be y minus 6, 6 is the y coordinate of the point, equals 1/2, the slope, times the quantity x minus 1, where 1 is the coordinate, the x coordinate that was given. Now this is a little trickier when you have negative values. So take a look at this one. You have a line with a slope of 2 going through a point -2, -3, and you're going to write the equation. Because the subtraction is built into this form, if your point is negative, it's going to become positive in point-slope form. So in this case, it's going to become y plus 3 equals 2 times the quantity x plus 2. Because you have to do y minus y1 and your y1 is negative, it turns into a positive. So if it's negative, it's always going to be the opposite value-wise. To graph in point-slope form, you have to understand the setup of the equation and be able to recognize both the point and the slope. You're going to begin at your given point and then use the slope to find 2 more points. So for example, given this equation, we're going to graph it. Y plus 2 equals 2/3 times the quantity x minus 3. Well, here right away you know the slope is 2/3 because the m is outside the x value in the equation. And the point here is 3, 2. Because it's x minus 3, your x value is 3. And because it's y plus 2, your y value is -2. That's where that trickiness with the negative comes in. What you're going to do is plot the point. So I started at 3, -2. You can see that here on the graph. And then I went up 2 and over 3 2 times. I'd like you to graph at least 3 points before you draw your line, and make sure that your line goes through both the x and y axis, please. It should go through all 4. I don't want to see a little teeny line in one quadrant. Now, if you're given 2 points, you have to calculate the slope first before you can write the equation in point-slope form. That's only logical. So in this example, you're given a point of -1, 3, 1, 1. So step 1 in writing the equation would be to calculate the slope. So you're going to take 1 minus 3 over 1 minus -1. Remember, it's always change in y over change in x, and that becomes -1. In step 2, you can write the equation in point-slope form using either point that was given. So you can either use the -1, 3 or 1, 1. Either one would be correct. In option 1, it could be y minus 3 equals negative 1 times x plus 1. Or in option 2, y minus 1 equals negative 1 times x minus 1. Either one is acceptable. If you actually went through and multiplied these out and brought all your x terms to one side along with your constants and left the y isolated on the left side, you'll find that both equations are equivalent. They're exactly the same if you put them in slope-intercept form. Now let's try a word problem using point-slope form. If you're creating stickers for a class project, for example, and the stickers are $225 for 1,000 and $80 for each additional 100, we're going to write an equation for the cost of the stickers. Now, because the increase in cost is already given, you should recognize that that's the slope. So you already know starting out here that 80 is the slope. You don't have to calculate it. And you're given one point. You're given the point 1, 225. Now, this might be confusing to you, but when working with large numbers, it's easier to work in thousands, millions, billions, etc. So here, 1 is going to represent 1,000. You don't want to be working with 1,000 in your equation. The numbers are going to get far too large. So using that 1 point and the slope that's given, it's really easy to write the equation in point-slope form. Y minus 225 equals 80 times the quantity x minus 1. You can then work with it this way, or you can convert it to slope-intercept form very easily by isolating the y on the left-hand side and bringing the x and the constants over to the right. So to find the cost of any number of stickers, you would substitute the value for x. You can use either equation to do this. I'm going to use it in slope-intercept form, actually. So to find the cost of 9,000 stickers, I would set x equal to 9. Be careful. You cannot use 9,000 here if you used 1 for 1,000 earlier in the setup of the equation. So this is going to become y equals 80 times 9 plus 145, or y equals 865. Now you should also be able to construct a model from real-world data in a table. Here I gave you the cost of people attending a resort for the number of people and the cost per night. The first thing you have to do when you look at this data is determine if it can be modeled by a linear equation, and then if possible you can write the equation. To determine if it's a linear equation, remember slope must be constant. So you have to look at all the points and determine the slope from point to point all the way across the whole data set. And that will confirm that you have a line. So I've taken consecutive points here to find the difference and divided by the change in x. And you can see that it's a constant 50 all the way across. That means that the slope is 50 for this line, and it is in fact a line. You can then use point-slope form to write the equation. And here again, you could use any point in this data set. If C is the cost in dollars here, and P is the number of people in attendance, then you would take C minus the value of any point here, and I use 250, the first point, and set that equal to the slope, 50, times the quantity P minus 4. If you change this to slope-intercept form, it also becomes C equals 50p plus 50, which you probably recognized at first when you saw it. Because you knew the slope was 50 and you knew the starting point was 50, then it's pretty easy to figure out. I think using this form is very, very simple and that you shouldn't have any trouble with it.